Welcome to Applying Net Change. Okay, so the most important formula of net change is also known as the first fundamental theorem of calculus, and it is as follows. So it is the integral of a to b of f prime of x, and that equals f of b minus f of a. And when you rearrange this, you get the more familiar version of this, which is and this is the net change equation, f of a plus the integral from a to b of f prime of x dx, and that equals f of b. And the important thing about net change is you use net change when you have both a value and a rate. So you have a starting value, you would have what f of a equals, and you have what f prime of x equals. So you use net change when you have a value and a rate. And that is one of the most important things of net change. This is a very standard net change problem, and this is how you would first start using it, just to practice using the formula shown above. And it is when you're given an initial value of f of 0 equals 1, and you have the rate, which is f prime of x, and that equals 3x squared plus 1, and you're asked to find another value, which is f of 3. And so you set up the equation as shown above, but you leave space for the a and the b and the f prime of x. So you would have f, and we'll fill that in later. And since you know that your a value is the initial value, then it's the one you're given. So f of 0 equals 1. So you put f of 0 here, and it's your starting value, and you're trying to find f of 3, so that will be, 3 will be your b, so it will equal f of 3, and these are your bounds. And you know that f prime of x dx is given to you right here, so you can just plug that in for f prime of x, and you can, and then you have your equation. So now you can just antiderive and plug in 1, and then you could find your f of 3, and I will do that now. And you know that f of 0 equals 1 because it is given to you. And then you just do that. And you finally got your answer, 31 equals f of 3. And the way I did this is that I found the antiderivative of 3x squared plus 1 using the rules of antiderivativeness. And I substituted 1 for f of 0 because it was given to us. and then I plugged in 3, and then I just anti-derived it normally, and I got 30, and then I did 1 plus 30 because you have to add the original value in the formula, and I wanted to find f of 3 because that was what the instruction said, and I found it, and it equals 31. Okay, so this is our first FRQ problem, and it is from the 2011 Form B, and it's number 1, and this is part A, and I will post the picture of it too. And it said, what is the height of the water in the can at the end of the 60-day period? And to know that this is a net change problem, you are given a value and a rate, because remember, you use net change theorem when you have both a value and a rate. So the value you know is s of 0 equals 0 because it said that the can was initially empty. So you know that the height would be 0 if it was empty. And then it gives you a rate which is modeled by this function 2 sine 0.03 t plus 1.5. And as soon as you get those two values and you know you have those values, you just think net change. And so the way you solve this problem is you refer back to the formula above, which by now you should have memorized because of the toolbox, but just in case, it's right up there. And so you know in the formula that f of a plus the integral from a to b of the rate of f, and that equals the value of f of b. And it's asking you what is the height of the water at the end of the 60-day period. So you know that b, which is the end of the bound, will be 60 because it said at the end of the 60-day period. And you know that the bound on the left side is going to be 0 because it said that the water at time t equals 0 is at 0. So you have your bounds right here. And so now we can plug it into the formula. So f and so you know that b is 60, so you just put 60 here, and that's the bound right here. And a is 0, so you put 0 over here. And then so you know that f prime of x is given to you in this equation, so you can just write that instead. And so you have this equation, and you have the bounds here. And since this is a calculator active problem, you can just plug this into your calculator and have it find the antiderivative for you. So you know that s of 0 equals 0 because that is what's the initial value given to you. So it's 0, and then it's plus this integral, which I've solved, and I have discovered that the answer is 91.884. And this all equals s of 60. And so 0 plus any number is that number, so you can just ignore that. But it's only for this problem because it said that the value at the beginning was 0. If it said that the value at the beginning was an actual number, you would have to add that and do the math normally. But since it was 0, you can just do the antiderivative and get your answer, and then the answer is 91.88. Okay, so this is the AP style question number 2, and it is one from the 2009 exam number 2. And part A says, how many people are in the auditorium when the concert begins? And it gives you an initial value because it says at the beginning there was no one in the auditorium, so that you know that t at time equals 0 is equal to 0. And they also give you a rate, which is modeled by 1380 t squared minus 675 t cubed. And so you know when you have a value and a rate, you use net change theorem. So we're going to use net change theorem. And refer back to this formula above or to your brain for the equation. So you have the f of a plus the integral from a to b, and we will determine those bounds very soon. So it says how many people are in the auditorium when the concert begins. And it also gives us a very important time interval that I failed to write on the board, and it's from 0 to 2. It says that at time equals 0, there's no one there, but the concert begins at time equals 2. So you know that the f of a would equal 0 because it is the value given to us, and it is the starting value, so a equals 0. And you know that the concert begins at time t equals 2, and that is your final value because it's asking you how many people are in the auditorium when the concert begins. So b equals 2, as shown here. And then you can plug in the rate equation right here, and right there, and then you can solve this rate equation. And since it is on the calculator section, you can just use your handy dandy calculator and solve that, and then you get f of 0 equals 0 because it's the value given. Okay, this would be t. Never mind. All the values are t. Forgive me. So t of 0 equals 0 because it's given to you. And this wonderful antiderivative is 980. And this equals t of 2. And this is what we're trying to solve for. How many people are in the auditorium when the concert begins? And since you're adding 0 to it, you can disregard this. But sometimes there will be questions where there are people in the auditorium at time t equals 0. So you will again have to just add it onto the answer. And this is your final answer. And just put units if you must. And that is it. This is how you apply net change.